Have you ever really stopped to think about the air you're breathing right now? I mean, really, think about it. What if I told you it has a secret language, a code, filled with hidden information about temperature, moisture, and energy? Well, today, we're going to learn how to read it.
Okay, let's start with a feeling you've probably had. The thermometer says it's 90 degrees Fahrenheit in both a steamy jungle and a dry baking desert. So why does one feel like you're trying to breathe underwater while the other just feels hot? Clearly, the temperature on the thermostat doesn't tell the whole story. Not even close. To get to the bottom of this, we have to look past that number on the thermometer. The real difference lies in the invisible properties of the air itself, especially how much water vapor it's holding. And believe it or not, there's a whole field of science dedicated to mapping these hidden qualities.
And that science is called psychrometry. Yeah, it's a bit of a mouthful, but it's basically the study of moist air. Now, don't get hung up on the word moist. In science, that's just the technical term for the mix of dry air and water vapor that's all around us, all the time. Understanding this mixture, well, that's the key to solving our jungle versus desert puzzle.
So, to start building our secret map of the air, we need to lock in two key coordinates. The first one is something we all know and talk about every day, but it's the second one where things get really interesting.
Our first coordinate is what's officially called dry bulb temperature. It sounds super technical, but it's just the fancy name for what we all call air temperature. You know, the number you see on the weather app or on your thermostat. It measures something called sensible heat.
And you gotta understand this difference. Sensible heat is the heat you can actually feel. It's what a thermometer measures. But then there's this other kind, latent heat. Think of it as hidden energy, tucked away inside the water vapor in the air. This, right here, is the secret ingredient that makes a humid day feel so exhausting.
All right, to really get this, let's try a simple analogy. Just imagine that the air all around you is a big, invisible bottle. Now, the temperature of the air, that determines the size of the bottle. Hotter air can hold way more water vapor, so think of it as a giant bottle. Cooler air, that's a smaller bottle. It's all about capacity. So, if temperature sets the bottle's size, then relative humidity tells us how full that bottle actually is with water. And you know a bottle that's 90% full feels a lot different than one that's only 10% full, right? And that's pretty much the textbook definition. Relative humidity is just the ratio of how much moisture is actually in the air compared to the absolute maximum it could hold at that exact temperature. So, in our jungle, that 90-degree air is a huge bottle that's almost totally full. The desert? Same size bottle, but it's nearly empty. Okay, so we've got temperature and we've got humidity. But how do they all connect to the other properties, like the actual energy packed into the air? Well, for that, scientists and engineers have this incredible tool that puts it all in one place. It's called the Psychrometric Chart, and I want you to think of it as the master key, the ultimate map of the air. Now, at first glance, it looks crazy complicated, but trust me, it's actually an amazingly elegant way to decode all the air's secrets. Let's just break it down real quick. Think of it like a graph. The foundation, that horizontal line along the bottom, that's our dry bulb temperature. The vertical axis, climbing up the side, that tracks the actual amount of moisture. And all those sweeping curves that arch across the chart, those are the lines for relative humidity. They show us how full the air is.
So how in the world do we use this thing? Well, this is where the magic happens. It works like a secret decoder ring for the atmosphere.
So get this. The whole point of the chart is that if you know just two things about the air, say its temperature and its humidity, you can find that exact spot on the map. And from that single point, you can instantly read every other property. It's all there. Okay, enough with the theory. Let's put this map to the test. We're going to walk through a real-world example and see this thing in action. So, let's say we measure the air and we get two pieces of info. We know the dry bulb temperature is 70 degrees Fahrenheit. And we know another property called the wet bulb temperature is 60 degrees. Basically, that's just a clever way to measure the air's cooling potential by seeing how much evaporation cools down a wet thermometer. Those are our two coordinates. Now, all we do is find the vertical line for 70 degrees and the diagonal line for 60 degrees. And right where they cross, that's our spot. That's our treasure map's X. And from this one intersection, we can now pull out all the rest of the air's hidden data. First up, we look at which curved line our little X is on. We trace it over, and bam! A relative humidity of 56.1%. Just like that, we know exactly how full our invisible bottle of air is. And now, from that exact same spot, we just read straight across horizontally to the edge of the chart. And that gives us the dew point, 53.7 degrees Fahrenheit. This is the precise temperature the air needs to cool down to before water starts to condense out of it, as dew or fog.
So, this is a pretty cool tool for scientists, but why does any of this matter to you and me? Well, it turns out this air map is basically running the modern world behind the scenes.
I mean, it is the absolute bedrock science for every efficient HVAC system that keeps us comfortable. It helps meteorologists predict things like fog and frost. It's critical for high-tech manufacturing, where conditions have to be perfect. And of course, it brings us right back to the start by perfectly explaining why a humid day feels so much hotter. It's all that latent, hidden energy in the moisture.
Look, the main takeaway here is simple. Psychrometry isn't some obscure, minor detail. It is the fundamental basis of heating, ventilation, and air conditioning. Every single time you walk into a climate-controlled building and feel that wave of comfort, you are experiencing the practical result of this chart.
So next time you feel a cool breeze, or you see your breath on a cold day, or you step out of the sweltering heat into a cool room, just remember the secret map of the air. It's not empty space around you, it's full of information. Now that you have the map, what will you see differently?